Okay, so we're back to our old friend, the purchase orders database for our two sample tests. Now, what we're trying to do is we're trying to test between two different products if there is a difference in order lead time. So what I'm going to do here is I'm going to type in lead time, and what we're going to do is we're first going to actually calculate the lead time as the difference between the order date and the arrival date. And I think I vaguely recall doing this for an earlier chapter, but we can use the Excel day function, so days function, that tells us the difference between an end date and a start date. So here J4 and I4, and we have 8, and let's just kind of select it, drag it down to the bottom, and then Control D, and you see it just populates down. So that's good. And let's just be pedantic and get it. It looks horrible at the moment. Why is it in a different font? So we're just going to do Arial 12 to make it look like everything else. And then, being really pedantic, we're going to go back and put our double bottom border in. So we want the lead time for alum sheeting versus durable products. So let's just select this table, and we really just want to sort it at the moment. The book also does a pivot table to look at the actual averages of mean times, but I don't think we really need to do that. We've done enough examples with pivot tables. So let's just select the top left of the table, select Control and Shift at the same time, down arrow, right arrow. Now let's go to the data, and let's go to sort, and let's sort by supplier. And you see here we have alum sheeting, and we have durable products, and let's just kind of hide anything that's not the lead time. So there we go. We have the lead times for each of these. Now, let's just kind of go and let's just take a little snippet of this. And let's just look what we're trying to say. So imagine we have alum sheeting is kind of my group 1, and durable products is my group 2. Then my kind of one-tailed hypotheses are as follows. Well, let's just actually here do this because it's kind of neutral. Let's just do the two-tailed first. So we'll actually go black. So we have two-tailed. The null hypothesis is the lead time is the same in each of these groups. The null hypothesis is that mu1 minus mu2 equals 0. And we could have actually written that as mu1 equals mu2. The alternative hypothesis is that mu1 minus mu2 is not equal to 0. So this would be the mean for alum sheeting. We could also have called it like, the mean alum sheeting, and mu2 is the mean for the durable products. So we're saying there's a difference here. We're saying there's a difference in lead times between the groups. And we could also write that as mu1 is not equal to mu2. Okay, and our two one-tailed tests. So I'm going to write the H1 here. We might want to say that mu1 minus mu2 is less than 0. Now, what does that mean? So if you subtract mu2 from mu1, we're less than 0. So that actually means that mu1, we could just put mu2 to the side, is mu2. So that would be durable products as a higher mean lead time than alum sheeting. And then the null hypothesis is that it doesn't. So it's kind of the opposite. So it's not less than, it's greater or equal to. And then we could actually write that as mu1 is greater or equal to mu2. And so that's my first one-tailed test. And my second one, I don't put the equal sign, but we'll just do the second one, which is going to be a greater than. So my second one-tailed test is going to be that mu1 minus mu2 is greater than 0. Or mu1 is greater than mu2. So the alum sheeting is greater than the durable products. And then the null hypothesis is that it's not greater than, it's less than. Okay, so there we have like the one-tailed test, the two versions of the one-tailed test. In the first one, we're trying to show that alum sheeting is less than durable products. And in the second one, we're trying to show that alum sheeting has a greater lead time than durable products. Okay, so let's go back to the Excel. And now we're on to it's suddenly easier, we're on to the data analysis toolpack. So we've got data analysis, and let's just go as follows. We've got, let's just look down. We're going to do we've got a 2 sample, and we can assume kind of equal variances, which is the student's t-test, or unequal variances, which is the Welsh t-test. For the moment, we're just going to be on the safe side. We're just going to assume, as the book does, unequal variances. Now, quite often, if you were doing this in a stats package, it would kind of work it out automatically. So let's just kind of click 2 sample, assuming unequal variances. And the variable 1 range, we're comparing alum sheeting with durable products. We were just testing if one was greater than the other one, so our hypothesized difference is 0. We don't have any labels in this data. We'll just put the output range. Where should we put it? We'll just put it somewhere here. And then we'll click OK. So just again, this was data analysis toolpack. 2 t-test, 2 sample, assuming unequal variances. That's kind of the safer option, and they usually give the 2 variants of the t-test usually give pretty much identical results. And what we're going to do is we're going to do variable 1, variable 2, and basically we're going to output it here. Okay? Right. So I love the fact it's kind of in very weird fonts, but let's actually put it so we can see it a little better. Let's just put it back in Arial. Same with everything else. That's looking a little bit better. So you see the mean for lead time for alum sheeting is 7. And the mean for durable products is 4.92. So the mean for alum sheeting is greater than durable products. But is it significant? Well, we have the variances, the observations, and then we would kind of calculate the t-statistic. Now, we have the t-statistic, and then we have the critical values for the one-tail and the two-tail. So if the t-statistic is greater than 1.81, then we reject for the one-tail upper test. If the t-statistic is less than minus 1.81, then we reject for the one-tail lower test. And for the two-tail test, we reject if it's less than minus 2.228 or greater than plus 2.228. So basically, we're going to reject everything because 3.827, it's greater than my 1.81 and it's greater than my 2.28. And the p-value is going to be less than any sort of alpha I'm going to have. So if my alpha is 0.05, my level of significance, we're less than this value, and here we're less than this value. And in fact, if you went back to the data analysis tool pack, you see we've got the alpha for our critical values is 0.05. We can actually change that. So if I change this to 0.01 and say had let's just output it down here, you will see that my alpha values are to reject are much, much higher because we've got a stricter test. But you'll see that they're still much less than my actual t-statistic. So this is actually quite a strong result. We reject for the one-tail and we reject for the two-tail. Let's just kind of, let's just make things a little bit nicer. Say this is alpha 0.05. Alpha equals 0.01. And let's just do home and Arial 12. So what basically what we're going to do is we're going to reject everything. So let's just kind of go back. Wrong one. Let's go back to my snipped tool. And let's just kind of go with a red pen. So as my t-value is greater than my critical two-tailed statistic, we're going to reject. So we're going to say reject H0. And my one-tailed, we're testing the one-tailed upper, i.e. mu1 is greater than mu2. So again, we reject H0. And here, you know, our mean difference, our mu1, in our sample, our x bar 1 minus x bar 2 is positive. So this is obviously not true, even without the statistic. Okay, so there we are. We have the little sample test.